Hi everyone, this is Logic Coding. Today we're going to look at a DP problem, count square submatrix with all ones. The problem statement is pretty straightforward. We're given a binary matrix consists only of ones and zeros, and we need to return the number of square submatrix have all the ones. Need to return the number, so that's one hint. And let's look at one example. So we are given this matrix, 0 and 1s, and we need to count all the square submatrix that have one square submatrix, also another key. If the entry is 1, then at this entry, at least, it have a submatrix of side 1. So it has 10 side 1. And if the left, above, and upper corner, diagonal upper corner are also 0, also ones, then at here we actually also have another square of side 2. So for this problem, we have 4 square of side 2, and at last we have 1 square of side 3. So we just sum them up to get the total number of squares. So let's consider how can we analyze this problem. So the first way is how can we solve it through brute force according to the definition. So for this example, let's just understand its definition. So for this example, for brute force, we need to first consider ij as the right down corner of the submatrix. And if it's 0, then if it's 0, we just have 0. If it's 1, we naturally have 1. Now we need to look back about the previous, consider how many this has, how many this has, and how many this has. And through this step, the time complexity would be OM square n square and n square. Can we do better? The answer is yes. Since we have some previously calculated results, we can use dp. Using the dp, we just define a state dpij as the number of sub matrix square submatrix have all ones at whose right down corner is I and j, and dpij transfer is dpij would be the minimum of dp I minus 1, j minus 1, and I minus 1 j dp ij minus 1 plus 1. Cool. So the next thing is initialization and output. Output, we need to collect all the subsquare ones. For each one, the right corner will end at I and j. Initialization, we can add one more layer to do the patch up and make every entry 0. Now let's code it up. First, let's do the sanity check. If the matrix is empty or it has no column, then we just return 0. Next, we get all the rows and we initialize our dp. Zero. Now let's loop through our matrix and update the DP4. Also, we need to have a counter, and at the end, I need to return this total for int I equal to 0 or 1, since we did our patch up. Plus int j equal to 1, smaller than columns j plus plus j. If our matrix I minus 1, j minus 1 have 0, then we can guarantee there is at least one submatrix there. We just add I and j, and we can just use this transfer function to update is equal to minimum of I minus 1, j minus 1, and minimum of j dp j minus 1. Cool. So the time complexity of this algorithm would be OMN, since we have to do at least one linear scan of all the matrix, and each operation takes constant time with constant time to get access to that constant time to do the minimization, and the space complexity would also be OMN, since we allocate the DP matrix. Let's run the code. Columns. Let's run it again. Let's try and submit it. Great.